Hello, this is the second video of lesson 8.1, still on page 501 of your textbook. I want to continue talking about the sum of the interior angles of any polygon. When two sides of a polygon and a vertex form what we call an interior angle of a polygon. A polygon has as many interior angles as sides. If you have a regular polygon, then that means that all the sides in that polygon are congruent and all its interior angles are congruent. And also, if it is a regular polygon, then it is a convex polygon. So let's say that we had a coin like this, and we had to find the sum. You see that? It has 11 sides. This is not exactly round. It has 11 sides. It's an 11-gon coin. Okay, if we had to find the sum of the interior angles, the 11 interior angles of this figure, what is the total sum of the measures of all those angles? We have a formula. It's right here. N minus 2 times 180, where n is the number of sides of the polygon. Number of sides in here, 11. It's an 11-gon. Number of sides of a polygon like this one, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 sides. Okay. Something else to review. Diagonals of a polygon. A diagonal of a polygon is a segment that connects a vertex with a non-adjacent vertex of a polygon. If I take this vertex here, these two vertices, this one and this one, would be adjacent to the vertex I chose. In order to draw a diagonal of a polygon, I have to connect to other vertices that are non-adjacent. Like, I can connect to this one, this one, this one, this one, and this one, since they are not adjacent to the original vertex that I chose. So I'm going to do that right now. I'm going to draw as many diagonals from vertex, let's call it vertex A, as I can. I have drawn 2 so far. There. I drew as many diagonals as I could draw from point A in this figure. And I ended up with 1, 2, 3, 4, 5, 6 triangles. And this is 1, 2, 3, 4, 5, 6, 7, 8-sided figure. 8 sides, 6 triangles. 1, 2, 3, 4, 5, 6 triangles inside this 8-sided figure. Remember those numbers now. We're going to come here and do example 1 of your book on page 501, where they ask you to use the polygon interior angles theorem, which says that this is a good formula to find out the sum of the interior angles of a polygon. So, example 1 requests that we find the sum of the measures of the interior angles of a convex octagon. I have an octagon here for you. Octagon means 8 sides, and they want us to find the sum of the measures of the interior angles. Here are the interior angles. 1, 2, 3, 4, 5, 6, 7, 8. Okay. They want us to find the sum of all those angles, of the measures of all those angles. Well, let's use our formula. How many sides does this figure have? It's an octagon, so it has 8 sides. So for this figure, for this polygon, n is 8. 8. Okay, so I'm going to use my formula. 8 minus 2 times 180, and that should give me the sum of all these little angles. Okay, 8 minus 2, 6 times 180, which is 1080 degrees. So the sum of all these angles, even though I don't know how much each one measures, is 1080. Now, if this were a regular octagon, which means regular, we said a regular polygon has all sides congruent and all interior angles are congruent. If this was a regular octagon, then I could take the total, the sum of all the angles divided by 8, and I would find the measure of one angle. So what do I have to do to find the sum of the interior angles of my coin? Well, use the same formula. N, which is the number of sides, minus 2 times 180 degrees, 180 degrees. Okay, well then, in this case, N is 11 because it has 11 sides, minus 2 times 180 degrees, and this will equal 9 times 180 degrees, which is 1620 degrees. So the sum of all these angles is 1620 degrees. Perfect. Let's work on example 2 of page 502. It says, the sum of the measures of the interior angles of a convex polygon is 900. What type of a polygon is it? Classify the polygon by the number of sides. How many sides does a polygon who has 900 degrees as the sum of the measures of its interior angles? Well then, let's write our equation. Okay, n, the number of sides, minus 2 times 180 degrees is 900. So this is a really good formula because it only contains one variable, and yeah, I think we can do it. To discover n, if we discover n, we'll know the number of sides of the polygon with this many degrees as its interior angles sum. So now we know the end result, we know the sum. We're looking for the number of sides. So this formula works well for this type of question also, as in example 2. So this binomial is multiplied times 180 equals 900. So